In this video, I'm going to introduce a third form of vector multiplication called cross products. We already know how to perform scalar multiplication, and we know how to find a dot product in R3. A cross product, which is also known as a vector product, is a third type of vector multiplication that happens in R3. A cross product combines two vectors in R3, and the result is a third vector that will be orthogonal to both of the original vectors. If I'm given two non-zero vectors u and v in R3, the cross product, which is denoted by the vector u with a multiplication symbol that's a cross, and the vector v, is a vector that has a magnitude given by the magnitude of the cross product of u and v is equal to the magnitude of u times the magnitude of v times the sine of theta, where 0 is less than or equal to theta, which is less than or equal to pi, and theta is the angle that lies between the vector u and the vector v. The direction of u cross v is given by something called the right-hand rule. When I put the vectors tail to tail and let the fingers of the right hand point in the direction of u and then curl to the direction of v, the direction that my thumb points will be the direction of the cross product, which is orthogonal to both u and v. When the cross product of u and v is equal to the zero vector, the direction of the cross product will be undefined. So the right-hand rule is simply represented by putting the fingers of the right hand in the direction of the first vector, u, then curl the fingers so that they point in the direction of the vector v, and the thumb sticking out from the palm is pointed in the direction of the cross product. If I let u and v be two non-zero vectors in R3, the vectors u and v are parallel, meaning theta is 0 or pi, if and only if the cross product of u and v is equal to the zero vector. So parallel vectors have a cross product that is the zero vector. If u and v are two sides of a parallelogram, then the area of the parallelogram will be given by the magnitude of the cross product, which is the magnitude of u times the magnitude of v times the sine of theta. Now let's talk about the properties of cross products. Suppose u, v, and w are non-zero vectors in R3 and that a and b are scalars. The first property of cross products is that u cross v is equal to the negative of v cross u. This is called the anti-commutative property. The second property is that a times the vector u cross b times the vector v is the same as the product of a and b times the cross product of u and v. This is the associative property for cross products. The third property is the distributive property, where I have the vector u cross the sum of the two vectors v and w. This is the same thing as u cross v plus u cross w. There's another form of the distributive property, which is the fourth property we'll go over. The sum of u plus v cross the vector w is the same as u cross w plus v cross w. Keep in mind that the cross product is not commutative, it's anti-commutative. So let's work an example. I want to sketch the vectors u given in component form as 0, 4, 0, and the vector v given in component form as 0, 0, negative 8. Then I want to compute u cross v and show the cross product on my graph. My first vector u lies along the positive y-axis. The vector v lies along the negative z-axis. The magnitude of u cross v is the magnitude of u times the magnitude of v times the sine of theta. Theta in this case is pi over 2 because the z and y axes are orthogonal to each other. This gives me sine of pi over 2 is equal to 1. The magnitude of u is 4. The magnitude of v is 8. So the magnitude of my cross product is 32. Using the right-hand rule, we note that u cross v will point along the negative x-axis, so that our vector for our cross product will be given by u cross v is equal to negative 32, 0, 0 in component form. my cross product vector will lie entirely along the negative x-axis. So now you get to try it. Pause the video and compute the magnitude of the cross product of u and v if the vector u is given in component form as 3, 0, 0, the vector v is given in component form as 0, 0, 4, and the angle between u and v is 2 pi over 3. When you're ready, restart the video to check your understanding. The magnitude of the cross product of u and v is given by the magnitude of u times the magnitude of v times the sine of theta. The magnitude of u is 3. The magnitude of v is 4. The magnitude of the cross product is given by 12 times the sine of 2 pi over 3. This is equal to 6 times the square root of 3, or approximately equal to 10.39. I want to note that by the right-hand rule, this cross product will be in the direction of the negative y-axis. I start by putting my fingers of my right hand along the positive x direction and curl them upwards so that they follow the positive z direction. My thumb will point along the negative y-axis. This is a quick introduction to cross products. Be sure and let me know if you have any questions about any of these basic ideas.